All right, 7.3 extension is going to go over two things about triangles. It's going to have you fill in missing angle measures in a triangle, which you should know how to do. And it's going to ask you to classify them, which we learned how to do yesterday. So this is number one. For number one, you're going to have to write two things down. What X is, and then what kind of triangle it is, based off of all of our different ways we can classify triangles by their angles and sides. So for number one, we can start by subtracting the two angles we do have from what number? 180. All triangles have 180 degrees. So 180 minus, and then 44 and 45, what does that combine to?
91.
91. 180 and, 45 and 44 combined to, actually not 91.
Oh, it's 80, 89.
9 and 5. Yeah, it should be 89. There we go. 89. Okay. So say double check the math there. We're adding the two angles we do have together. 45 and 44 should make 89. When you subtract 89 from 180, what's left?
91.
That's where the 91 comes in. And so the way that we're going to label this will be the same on your quiz tomorrow. You're just going to put X equals 91. You don't need to put 91 degrees because so for some of these going to solve them as an equation. So I'm just going to say label your answer with X equals, just like they did. They have an X equals right there and then they have the box. So you type in 91. Now, classifying our triangles. We can classify them by their angles and by their sides. If we have any angles that are 90 or above, then we have a right or an obtuse triangle. If we don't have any of those angles and all three of them are acute, then we have an acute triangle. What kind of triangle would this be? Right, obtuse, or acute? Jude.
Oh, right scaling.
Not right scaling.
What?
Is he?
Obtuse.
It would be obtuse. You're right, because we have the 91 degree angle here, which is bigger than 90. Okay, so it's obtuse, and scalene is correct. Now, scalene triangles don't have any equal sides. Well, how do we know it doesn't have any equal sides? We learned yesterday that if a triangle doesn't have any equal angles, it won't have any equal sides. And so since none of these angles are congruent, none of the sides are. So I'm looking for obtuse, scalene, which is right there. And I've got both my answers for number one. Moving on to number two. Finding the value of X, I'm going to do the same thing. 180 degrees. That's how many degrees are in every triangle, minus the total degrees that I currently know that are in that triangle. What will I get for 78 and 27? 105. So I subtract away the two angles I already do know. Whatever's left over is how big angle X is. How big is angle X? Of all the people working on this, it should be more than just two people raising their hands. I know that not everybody's working on this right now, but more people than this can be able to do it. Yes. 75. So just put X equals 75, and you've answered the first part of number two. Now, for the second part of number two, do we have any angles that are 90 or above?
No.
No. So that makes this an acute triangle then. If all three angles are acute, then it's an acute triangle. Remember, just seeing that one of them is acute isn't enough. Every triangle in existence has two acute angles, at least. If they all three are acute, then and only then is it an acute triangle. This one's an acute triangle. Are any of the angle measurements congruent? No, so none of the sides will be congruent. What do we call a triangle with no congruent sides? Scalene. I'm looking for acute scalene. It's the second choice. Acute scalene. Circle it there. Number three. Start off with 180 minus, and then the two angles. So again, this is like what we did on the triangle worksheet, the problems we were solving for that missing angle. There's a few problems that were like this. So 180 minus, and then 53 and 37. What does that add up to? 90. So I'm going to do 180 minus 90, and 180 minus 90 is 90. So this missing angle, X equals, go ahead and put X equals 90. So it's a right triangle, yes. Are any of the angles congruent to each other? Jude? No, they're not.
Right scaling.
So it's right scalene. That's exactly right. It's right scalene. Okay. Number four. Number four, we'd start off with 180 degrees minus the two angles we do have. What's 73 and 13 add to? 86. So 180 minus 86. 94. So this is x equals 94. And if we have an angle that's bigger than 90, what kind of triangle does that make this? Obtuse. Are any of the angles the same? No, so none of the sides will be the same. And if none of the sides are the same, scalene. So far, they've all been scalene, haven't they? So I'm looking for obtuse, scalene. Obtuse, scalene is one of the options. Number 5. Number 5, we know that we have two equal or two congruent sides. So for once, we can actually say that this triangle is not going to be scalene. If it has two congruent sides, it's going to be what, Jude? Isosceles. It'll be isosceles. Now, if we have two congruent sides, that means two congruent angles. So angle X is either 48 or 84. Which one do you think it is? Yeah, it's 48. I mean, we could actually do this without showing any work. Again, we know that if it has two congruent sides, it will have two congruent angles. So angle X here is either 84 or 48. Well, you can't have 84, 84, and 48 because that's not a 180. But 84 plus 48 and 48 would make 180. And we already said it's isosceles. Are there any angles that are 90 or more? Not on this one. So it's all of them are acute angles. So this one, we're looking for an acute isosceles triangle, which is the very first option, acute isosceles. Acute isosceles triangle. All right, moving on to number 6. Number 6, I don't have to do any work on number 6 either, because I see 3 tick marks showing me that I've got 3 congruent sides. And if I have 3 congruent sides, how many congruent angles am I going to have? All 3 angles will be congruent. So if 2 of them are 60, guess what X is? 60. Yeah, didn't we say the other day that yesterday, I think we said that if it's an equiangular triangle, all equilateral triangles are equiangular. And if they're equiangular, take 180 degrees and split it 3 ways. All equiangular triangles have to be 60 degrees. That's right. So this X is 60. And then there should be an option that says either acute equilateral or there it is, equiangular equilateral. Tomorrow in your quiz, I'll accept acute equilateral or equiangular equilateral. You need the word equilateral for sure, but if you want to say, like, you're not wrong if you tell me that's an acute triangle. It is an acute triangle. You could also say it's equiangular. Number 7, this is an interesting problem. It says, tell whether the triangle can have the given angle measurements: 76.2 degrees, 81.7 degrees, and 22.1 degrees. Well, it can have those given angle measurements if they add up to what? You're thinking side. They have to add up to 180. Yes. So do that. You need to be sure about this. You need to be sure that they add up to 180. It's hard to tell when you use decimals like that. You're getting them to add up to 180. So anybody else? No, you're not. Uh-oh, we're conflicted. We're conflicted. I need to know. I can't move on. It can what? They add up to 180?
Yeah.
It's not. I got 180.9.
Try yours again, because I'm getting multiple. Has anyone else gotten 180 when they add them together? Okay, so if they add up to 180, does a triangle exist with these measurements? Sure could, yeah. So a triangle can have these given angle measurements. Now, if you had me, and again, some of you haven't had this yet when we talked about unique triangles, but if I give you the 3 angle measurements of a triangle and they add up to 180, it can definitely be a triangle. Is it a unique triangle? Does anyone remember?
Yeah.
Is there a unique triangle classification that says AAA?
No.
There isn't one. It says SSS. And so if I give you the 3 angles of a triangle, you could actually make the sides however long you want to, and still keep the angle measurements there. So this isn't going to be unique. And so if I was answering this question on a quiz tomorrow and it said, here's the 3 angles, can you make a triangle? If they add up to 180, the answer is yes, you can. And you can make many triangles with these angle measurements. The side lengths could be many different sizes. That's not something we have to answer on this one. Now, the second part says, if it's not a triangle, if the angles don't add up to 180, change the first angle to force them to add up to 180. But since these do add up to 180, I don't want to change the first angle at all. I want to leave it at 76.2 degrees. So I'm not going to change the first angle because we are good here. We are good. These add up to 180. Number 8. Can someone add those up and see if we get 180? Izzy, you don't. What did you get?
I didn't really do it.
Oh, well, I'd like someone to be sure.
Oh, they don't.
If they don't add up, you can just look at
It's
it.
255.
It's 255.6. Yeah. Now, Jude, you said you could just look at them.
Yeah.
What did you mean by that?
Well, 90, first of all, 93.
Go ahead.
First of all, 115.1 plus 93 is already over 180.
You're right. This triangle, if it were a triangle, would have 2 obtuse angles. You can't have a triangle with 2 obtuse angles because you're already over 180 degrees. You're right. So I already got 2 angles that are over 90, and that can't happen. So what we're going to do is we're going to put cannot, a triangle like this cannot exist because doesn't have 180 degrees. We're going to change the first angle so that it does add up to 180 degrees. So what I want you to do is scratch out, I guess, maybe you can't scratch it, I don't know, but we're going to think of it as just being an X now. So if it's not 115 point whatever degrees, 0.1, I think, if it's not 115 degrees, then it's going to be something else. And so we're going to treat this problem just like we treated all these. We do know the other 2 angles, so we can find the third by subtracting from 180. So where am I at here? So then I take 93 and 47.5, 93 plus 47.5 is 140.5, and I just subtract 180 minus the 2 angles that I know are good. And what did you say that was? 39.5. So we're going to change the first angle to be 39.5 degrees. You'd have to put both. Yes. All right, number 11. Number 11, we're back to finding the missing angles in a triangle. This one has an X and another X, but I do know that all 3 angles are going to add to 180 degrees. So I can say that angle X plus the other angle X plus the 45-degree angle have to add up to 180. I know that's true. And we've solved lots of equations that look like this recently, right? In our 2 big ideas homework assignments. What's 1x and 1x make? 2x. So I can just combine those together and say that's just going to be 2x. I want to stop for a second. Does everyone see where I got the 2x from?
Yeah.
X plus x. Does everyone see why I added the 3 together and set it equal to 180? It's this triangle. Okay. Now, do I get rid of the 2 or the 45 first? 45. The opposite of a plus 45 is a minus or negative 45. Yes, both those will work. So I put minus 45. Can someone tell me what 180 minus 45 is, Sam? 135. So I got 2x equals 135. And now my favorite part, I just hit divide by 2 in my calculator. I don't like that. I think you did 45 divided by 2. 67.5. Yeah, 67.5. And I just put x equals and that's it. Now they want me to classify this triangle as well. So if I know that this angle here, change my color on that. If I know this angle here is 67.5 and that one there is 67.5, I know 2 angles are equal, so 2 sides are equal. And so this will be isosceles. Are any of the angles over 90 or 90 or above, I should say? It's no, yep, so it's an acute. None of them are 90 or above, so it's an acute isosceles, and that is the first option. So we had to solve an equation. Did everyone get the equation written down on their paper? Okay, I'm going to leave it up there for about 15 more seconds if you need to copy that equation down before I move on. And we said it was acute isosceles. And actually, you can even see right here, you can see the tick marks. So we should have known it was isosceles without even finding what X is. Is anyone still writing down the equation? Number 12. Number 12, this is another problem I could create. Actually, you know what? I don't need the equation. All three sides are congruent. So all three angles are going to be congruent. So if one of them is 60, they're all 60. This is an equilateral triangle with three 60-degree angles. So X has to be equal to 60. We've already had one like this. You can tell all three sides are congruent because they use these three tick marks right there showing you they're all the same. So all three angles are going to be the same. And what do we call a triangle that's all, okay, equilateral, and all three angles are the same? Acute or equiangular. Yeah, I would take acute equilateral. That's just not one of the options they have. You ready to take it back over? Number 13. By the way, Christian, if you want to start your math, I can give you all of your success time period to work on it as well. Okay. Number 13, this one I'm going to have to set up an equation for. Are you okay if I just go ahead and say that 1x and 1x is 2x? Okay, so instead of having to write it down multiple times, and then I'm going to add the 132-degree angle to that, and it's going to give me 180 because this is a triangle. So that's the equation I can write. Do I get rid of the 2 or the 132? Yep, get rid of the constant term by putting a minus 132 underneath of it to get rid of the plus. And can someone tell me what 180 minus 130, 48? All right, so 2x equals 48. And now I'm ready to hit divide by 2. Divide by 2. Jude? 24. So I got two 24-degree angles right there and right there. So I know there's two equal angles and two equal sides. Is it scalene, isosceles, or equilateral? Isosceles. Are there any angles that are 90 or above? Yeah, which one? So is it a right or obtuse triangle? It's obtuse. I'm looking for obtuse, isosceles, and that is one of the options. Number 14. Number 14 and 15, the equations get ramped up just a little bit. I'm not going to do anything different. I'm going to add all three of them together. And what do all three angles add up to? 180. So if you know that, nothing really changes. The first angle I'm going to write down is 2x plus 15. Okay. Plus there's another x angle. Plus there's a right angle. And what's that measure? 90. And all three of those angles have to add up to 180 degrees. So again, I put the 2x plus 15 angle down, then I put the x angle down, then I put the 90-degree angle down. Yeah. And now I'm going to combine my terms, and there are definitely some terms that can combine. What does 2x and 1x make? 3x. What does 15 and 90 make? 105. So I can simplify that giant equation down to something that looks a lot more familiar to us. Do I get rid of the 3 or the 105? Yep, get rid of your constant term first. Leave the 3 that's being multiplied, leave it for the end. So we're going to subtract 105 from both sides. What's 180 minus 105? 75. And then now to get x by itself, divide by 3. That's right. We get Sam. 25. X is 25. There's the first part. Now we said there's a right angle, so this is definitely a right triangle for sure. Are any of the angles going to be the same? No, if I plug 25 in here, I'm not going to get the same angle I'll get when I plug 25 in here times by 2 and add 15 to it. So none of the angles are the same. So none of the sides are the same. What do you call a triangle with no congruent sides? Scalene. Looking for right scalene. Yes. Right scalene is one of the options. Number 15. Whew, it's a lot of angles. Well, it's actually not a lot of angles. It's just each one's got a lot of parts to it, right? It's just 3 angles still. I mean, it is a triangle. X plus 10 is my first angle. plus x for my second angle, plus 3x minus 5 for my third angle, and they all have to add up to 180. So it's just me putting a bunch of plus signs between them. Now there is a minus sign. That's because one of the angles was 3x minus 5. All right, let's combine. 1x, 3x, 5x. 1 plus 1 plus 3 is 5x. 10, and be careful here, -5. 10 and -5 would just make 5. Now, is it a positive or -5? It is positive. Do you remember your integer rules? You go to war, larger army always wins, right? So we have 5 good guys left over after they do that 10 and -5 battle. And that's going to now be equal to 180. So this is a lot more manageable for us, a lot more manageable. Obviously, I'm going to get rid of a 5. Get rid of the one that's the constant, the one that's not with the x, by subtracting 5 from both sides. 180 minus 5. 175. 5x equals 175. Now we divide. What is it? 35. 175 divided by 5 is 35. Okay. Now, are you finished? So when it comes to classifying, thank you, I need to know if any of these angles are going to be 90 or more. And so what I'm going to do is I'm going to plug in 35 to this angle. This is the one I'm worried about. I know that that's 35 and I know that that's 45 just by adding 10 to it. But I need to know what happens when you take 35 and you times it by 3 and take 5 away. What's 35 times 3? This is important. Otherwise, we're not going to be able to classify this.
105.
105. What's 105 minus 5?
105.
So this is a 100-degree angle, and that's important because now I know what kind of triangle it is. Obtuse. It's obtuse. Are any of the angles the same? No, so none of the sides are the same. So obtuse, scalene. Obtuse, scalene triangle. And then the last one, number 16, explain why all triangles have at least 2 acute angles. And I've already said this in many different ways. Every triangle has at least 2 acute angles. If 2 angle measurements of a triangle were each greater than or equal to 90 degrees, meaning I had either 2 right angles or 2 obtuse angles, then the sum of all 3 angle measures would already be more than 180 degrees, which is not allowed. So you're not allowed to have 2 acute angles or 2 right angles. I would hope so.
Yeah.
All right, now you can take a picture of your work paper, which I am grading. You can take a picture of it, post it to the 7.3 extension, not the 7.3 answer paper, which is the one where you did yesterday. And you should be good to go. If you need to head back over, actually, not do you need to, go ahead and head back over. So there's open seats for everybody who's been sitting on the floor like me.
Well, I only did it
As long as
because
you're
everyone else took Steve, so,
You were the last one over here, I think, so.
yeah.